Hello everyone. In this video, you will learn how to integrate a function raised to a power. This is the indefinite integral of u raised to exponent n multiplied by the differential factor of du. Notice that the same basic definition for integration still apply, right? So in order for you to integrate this, you need to add 1 to the exponent and then you divide it by the result. And don't forget the plus c because you are dealing with indefinite integral in this case. But this formula applies for u to the exponent n and du. Alright, so I would like to introduce a unique method to everyone. It's called substitution. In order for you to use substitution, you have to consider u to the exponent n and multiply by du. These two factors are the product. Okay, so u to the exponent n times the du. U is a function raised to the exponent n, and du is a differentiation of u. It means that you have to take derivative of u in this case. For this method, we will have to work with both derivative and integral. A reminder to everyone that integration, differentiation, and algebra, they go very well together in this method of integration. So let's start it with this example number 1. Okay, so all of these examples in this lesson will appear in the form that a function raised to a power. Okay, so before we get started with example number 1, I would like everyone to pause a few seconds and think about when you are about to solve for an integral. You may want to analyze your integrand first. Okay, so before I'm doing this, I would like to review to everyone what we have done in the previous lesson. Okay, in previous lesson, I only show everyone up to this formulas right here. All right, and then today we introduce these formulas. Okay, so far we only have indefinite integral of x raised to a power. You see x raised to the power of n, and because of the function in terms of x, you have to have a differential factor of dx. Then again, you add 1 to the exponent divided by the result in this case. And then we've learned about the sum and difference of two or more functions as the integrand. And then you can break them into individual integrals, then integrate each of these integrals. Then you have a constant multiplied by a function. Then you can bring that constant across the integral sign. And what we have in this lesson is you are going to integrate a function raised to a power. Because of u, you have to multiply that with the differential factor of u. Okay, I use the word differential factor. Differential factor means that you multiply by derivative of u. Okay, so far we have learned only this two formulas and also these two properties of integration. Then we have to apply all this to this question. Okay, so using substitution means that you are going to identify u in this case. Identify u, and then you are going to find the du. Okay, so let u equal to x to the exponent 5 plus 2 in this case. If I let u equal to x to the exponent 5 plus 2, at the same time, since I apply substitution method, so I immediately substitute the expression x to the exponent 5 plus 2 as u. So that means u raised to the exponent 7, right? So now I'm going to ask everyone that the formula said you need to have a du. Okay, so that means in here you have to have something with the du. So how do we find that du? It means that we need to take derivative of the function u in terms of x. So you cannot write just du, you have to write du over the dx as the proper symbol for finding derivative of u. So derivative of u will be 5 times 1, which is 5. Then take 1 away from the exponent, which is 4. Then plus 2 is equal to, derivative of 2 is equal to 0. So I'm asking everyone to isolate the unknown du in this case. Alright, so that means you want to separate your variable in this case. So you want to turn this one side of the equation into du, and you want to turn this one side of the equation into x, and then multiply by the dx. So I will write du equal to 5x to the exponent 4 multiplied by dx. Now notice this. Okay, notice this. You have 5x to the exponent 4 times dx is the exact match of your 5x to the exponent 4 dx. So now instead of writing 5x to the exponent 4 dx in this case, I will just substitute that with the du, right? Okay, so I will substitute that with the du. So in fact, it's just equal to du in this case. And this is done because we already have the exact match of our differential factors. Okay, now I can apply the basic rule or the basic definition for this. So it means I can add 1 to the exponent and then I divide it by the result, right? So at 1 to 7, I will have u to the exponent 8 and I divide it by 8. Don't forget the plus c. And at the end, for my final answer, I'm going to substitute u by whatever I let u equal to, which is x to the exponent 5 plus 2, all of it raised to exponent 8 divided by 8 plus c. Okay. For this substitution method, we can avoid a lot of guessing in this case. Alright, okay. So all you have to worry at first is to make sure that you choose the right u. So if you happen to choose this 5 times x to the exponent 4 as u, when you differentiate that, you don't have anything very close to this, then you know for sure that you should choose x to the exponent 5 plus 2, all of it, as the u. Okay? You had 50% chance here. So try to choose one or the other, but after we are working with a few examples, I am very sure that you will recognize right away what function to choose as your u. Okay, so let's start with example number 2. So for this example number 2, obviously you see that you will let 3 multiply by x to the exponent 6 plus 4 as the function of u. So I'm going to let u equal to 3x to the exponent 6 plus 4. Okay, so I'm using substitution method. So at the same time, I am going to write my integral of u to the exponent 6. And I'm going to have a box right here with a question mark because I need to have the du in here somehow. Okay, so in order for me to get that du, I need to differentiate this function u in terms of x. So derivative of 3x to the 6 will be 18x to the exponent 5. Take 6 times 3, which is 18. Take 1 away from the exponent, 6 will become 5. And derivative of plus 4 is 0. So what I'm going to ask you is now take a look at the rest of the integrand in the original question. It said x to the exponent 5 dx, and you want the exact match right here. Alright, the exact match. So what you need to do is you are going to divide 18 over to the side of the equation, and then you multiply dx over to the other side of the equation. So now you see the algebra will have to apply over here. And then I check this side is exactly equal to what I want to achieve. then instead of writing x to the exponent 5 dx in here, I will write it in terms of du. But the du now becomes du divided by 18. Alright, so this is done. So I am going to write in here du divided by 18. So I multiply by du divided by 18. So up to this point, you can see that you can bring 1 over 18 across the integral sign. So 1 over 18 times u to the 6 du. Alright, okay. So 1 over 18, the integral of u to the 6 times du. And now go back to our formulas. So you see the exact match of what you need to use. You have u's raised to the exponent and then du. So you can go ahead and apply this formula. Add 1 to the exponent and divide it by the result. Okay. So if I add 1 to the exponent, it means that it becomes 7. So I write u to the 7. And divided by 7 means I will multiply by 1 over 7. And don't forget the plus c. And in the end, all you have to do is just simplify and replace u by the function 3 times x to the exponent 6 plus 4. So I should have the answer as 1 over 126 times 3x to the exponent 6 plus 4, all of it raised to the exponent 7 and plus c as my final answer. Alright, let's move on to example number 3. Okay, so what I will do is I will write the integral of 1 minus 2 times x to the exponent 4, all of it raised to the exponent 1/3. Okay, and you may want to put negative 5x to the exponent 3 dx together, because this is the somehow related to your differential factor du's. Alright, so I'm going to let u equal to 1 minus 2 times x to the exponent 4. So if you do that, it means your integral of u to the 1/3, and we need to write something in here. Okay, yeah, so we are going to figure out this question mark. Okay, so in order for me to figure out this question mark, I'm going to have to differentiate this u, take derivative of this u. You see that derivative of 1 is equal to 0. Derivative of negative 2 times x to the exponent 4. Negative 2 times 4 will give me negative 8. Take 1 away from the exponent, it will give me 3. Okay, so what I'm going to ask you to do next is to isolate your variable u, or in the way that I would use the word separating the variables. It means you want to multiply dx over to this side. Okay, so I'm going to multiply dx over to the other side. So it means I will have du equal to negative 8 x to the exponent 3 times dx. Okay, so but you need negative 5 times x to the exponent 3 dx in this case, right? But here you have negative 8. So what do we do in this case? Okay, I can divide both sides by negative 8. So du divided by negative 8 equal to x to the 3 times dx. And I need a negative 5, so I multiply by negative 5. That means I multiply by negative 5 here. Okay, so now you see this and that, the exact match already. So what do we have on this side? Negative 5 times du divided by 8 will give me 5 du over 8. Alright, okay. So the question mark now will become 5 over 8 times du. I can go ahead and bring 5 over 8 across the integral sign, and I end up with u to the exponent 1/3 times du. Okay, so this is done. So let's put it in make a note of this. Alright, so then you can go ahead, add 1 to the exponent, and then divide it by the result of that. So I should have 5 over a here, okay, and I will multiply by 1/3 plus 1. 1/3 plus 1 become 4/3. So u to the exponent 4/3. It means I multiply by 3 over 4. Okay, so this plus c. So let's see what we have. We can simplify by this will be equal to 15 over 32, and what we have is 15 over 32, and I will replace u by 1 minus 2 times x to the exponent 4, all of that raised to the exponent 4 over 3 plus c. Alright, you see it's pretty simple if we are using the substitution method, and we don't have to guess anything in this case, right? We apply differentiation, and we apply some manipulation of the equations here, separating the variables. We try to find the exact match for this. And then instead of writing -5 times x to the exponent 3 dx, you just simply write the equation in terms of u on the other side. Okay, so in this case is 5 times du over 8. Okay, substitute it in here, bring the constant across the integral sign, and then just apply the basic rule for integration for this particular integral. Alright, so I think I have one more example. Okay, before I integrate, I will start with having to convert this denominator to certain exponent. Okay, so I will bring it to the numerator and change that into a negative exponent as well, because you have a quotient in this case. Okay, and apply the basic rule for integration. We are going to convert this denominator into an exponent, and then we can bring it to the top and just to eliminate the denominator. So I will write the integral of -6 x to the exponent 3, and this one will be multiplied by 3 times x to the 4, subtract 5, all of it raised to the exponent -1/3 dx. Okay, so I would like to go back to this example number 3. Do you see right here we have -5 x to the exponent 3? I kept the exact same -5 x to the exponent 3 dx, but if you notice that -5 times x to the exponent 3, -5 considered as a constant, which you can bring it across the integral sign, but I did not do it in this case. Okay, but what I'm going to do is I will bring this -6 across the integral sign. In the end, all the process is still the same. Okay, so -6 integral of 3x to the 4 minus 5, all of it raised to the -1/3, and I will write x to the exponent 3 times dx together, because what I notice is that I'm going to use base on this so that I can separate my variables. So we are going to let u equal to 3 times x to the exponent 4 minus 5. Immediately after, I will differentiate this function, and I make sure I write du over dx. So derivative of 3 times x4 is 12, x to the exponent 3 minus the 0. And what you do next is you are going to make sure that your right hand side of this equation will be equal to x to the exponent 3 dx. So it means I will multiply dx over to this side, right? And then I divide 12 over to this side. Okay, So I take a look at this. I have the exact match already. It means I can go ahead and I will substitute -6 integral of now u raised to exponent -1/3, right? And instead of writing x to the exponent 3 dx, I will write the du over 12. Okay, so du over 12, it means that I multiply by 1 over 12, so I will bring this across the integral sign. And then u to the -1/3 in this case, du. Okay, so let me fix the 1/3 here. The -1/3. Okay, so simplify the constant in front of this. I should have -half. Okay, so now we are going to apply the integral, the definition of integral for this, or the basic rule for integration for this. You take -1/3, you add 1. Okay, so -1/3. Okay, sorry everyone. Honestly, I am recording this lesson at 4 a.m. in the morning, so I think it's time for me to rest, I believe. So I can quickly go over this with everyone, and then I will stop for the day. So -1/3 plus 1. In this case, you can use your calculator, or it's actually, let me show everyone the quick way of adding the fraction here. So I should have 2/3 as the answer. Is that right? Okay, so 2/3. So put this in the cloud. 2/3. It means that I will have to multiply by 3 over 2, right? Because you divided by 2/3. Okay, it means you multiply by 3 over 2. So now here I should have u raised to the exponent 2 over 3. Don't forget the plus c. And in the end, you simplify, you should have -3 over 4. And substitute u with the function in terms of x. So x to the 4 times 3. Subtract 5 in this case. Alright, raised to the 2/3 plus c. Okay, so very good. Okay, I have a few minutes left, so before I tell everyone that divided by 2 over 3, that means you multiply by 3 over 2. So I can quickly show everyone as a step below here. Okay, so you have -1/2. Okay, and you have what? You have u to the 2/3, and you divided this whole thing here, right, by 2 over 3. So it means that you are going to invert this fraction and change that into a multiplication. So that's why I said divided by 2 over 3, you multiply by 3 over 2. And you actually write it in here as a shortcut. Okay, so divided by 2 over 3 means that you multiply by the reciprocal of 2 over 3, so you multiply by 3 over 2. Okay, thank you everyone. Don't forget to complete the practice exercise here, that I have quite a few questions for everyone to complete. Alright, thank you.